Hey everyone, I hope you're doing well. So in our last video, we went over how to create a 3-bus network in PowerSET, and today I want to cover how to add transformers to PowerSET. So first thing we're going to do is we're going to open up our network that we saved in our last video. So I'm going to go to File, Open Network, select our network, and click Open. And then there is a network that we created. So what I want to do is I want to add transformers at our Gilbert and Mesa substations. They're going to connect on the high side of these transformers, and then connect on a low side bus, and then we're going to move our loads to those load side buses. So first thing I'm going to do is I'm going to create the low side buses. I'm going to go over here to our facilities, make sure buses is selected, and then click add. And you'll see that our ID was automatically incremented to the next available ID, which is ID 4, which makes sense because we have 3 buses in our network. So let's change our name. Let's call this Mesa T1, representing Mesa Transformer 1. And then our base voltage, let's choose 15 kV, and then hit add. And now let's do the same thing for Gilbert. Add. All right, now let's create our transformers. I'm going to go to Transformers and Facilities, and then click Add. And then for the transformer name, let's call it Mesa T1. And the from bus, let's make that the Mesa 100 kV bus. And the to bus, let's call that the Mesa 15 kV bus, which is ID 4. All right, let's skip the memberships. Controls, status, closed, of course. In control mode, we can choose between fixed and regulating. Right now, we're going to do fixed. And later on in the video, I'll show you how to make the transformer regulating. So we'll select fixed. From to base, this is your base MVA for your transformer impedances. Typically, your network is at 100 MVA base, but this gives you the option to specify the specific impedance base MVA. But for simplicity, let's keep it at 100 for now. The from nominal voltage, 100 kV. To nominal voltage, 15 kV. You can probably notice if these are just the bus base kV values, these can change, and that will affect your voltages at the low side of the transformer. And I'll show you how to do that later, but let's call that 115 for now. Your tap positions, let's keep these at 1 per unit. If you were to change these, we would also change the voltage on the low side of the transformer, but we're going to keep that at unity. GMB, these are your transformer core losses. They are typically very small. Let's assume for simplicity that they're negligible for now. And then your R and X values, these are your winding losses. I'll just make up some values of 0.01, and we'll assume that the X value is 8 times larger than the R value. So we'll put in 8. And then this is going to be a delta Y transformer. That's pretty typical for distribution. And you're going to have a 30 degrees phase shift. So remember, the American standard for a delta Y transformer is that the high side leads the low side by 30 degrees. And then for our ratings, let's make it 100 MVA, and then we'll assume that the emergency rating is 25% greater, so we'll put in 125, and then we'll disable the closing angle. And we'll click Add. And then we'll do the same thing for Gilbert. Gilbert T1, and then we'll change our buses to Gilbert. Just like that, and then we'll hit Add. Okay, so now we need to change our loads from the high side bus to the low side bus. So I'll go to Loads in the Facilities section, and then I'll select my Mesa load and click Edit. And then the from bus ID, I'll change that from 2 to 4, which is the Mesa load side bus, just like that, and hit Save. And then I'll do the same thing for Gilbert. Change that to the Gilbert low side bus. You'll notice that the loads disappeared from my one line. That tells me that they changed locations from a bus that does not exist on the one line. So I'm going to hit solve, and you'll see that our network converged in 9 iterations. And now I'm going to add it to our one line. So I'm going to right click on my Mesa bus and click Add Adjacent Bus and select Mesa T1, and then click somewhere, and then that will draw it off to the right, just like that, and do the same thing for Gilbert. Now I'm going to add a pivot point on the high side of the transformer, and then move the load side over there. So it all fits in one frame. All right, and with these distribution transformers, I'm not very concerned with what the flow is on the low side of the transformer because I know it's just going to match what the load is. You'll see that these values here are equivalent. So what I'm going to do with edit mode selected, I'm going to right click on the transformer, click edit transformer, and you'll see that this takes me directly to the one line properties of the transformer, and I'm going to unselect show two values. And you'll see that our two values disappeared. Do the same thing on this transformer. And in their place, I'm going to add a meter point. Just like that. All right, and now what I want to do is I want to differentiate with my color scheme, the high side and low side buses. So I'm going to go to Tools, Edit, Network Settings, One Line Settings, Edit Base kV Colors. So you'll see that all of our base voltages, 0 to 9,999 kV, are all cyan. So what I'm going to do here is I'm going to go from 0 to 15 kV. We're going to keep that at cyan. And then I'm going to enable this row, where we're going to go from 15 to 9,999. And let's make that this dark yellow color. And I'm going to hit save and cancel. So now you can differentiate our high and low side buses by the color scheme. Here, the high side is the dark yellow. And then we have the low side, which is our cyan color. I'm going to go ahead and save this so we don't lose our changes. Go to File and Save. And then I'm just going to overwrite what we have. Now that I've shown you how to add transformers to PowerSET, now let's talk about how we make them regulate the voltage on the low side. So there's two ways to do that. I'm going to uncheck edit mode, and now I'm going to select edit transformer. You'll see that takes me directly to the parameters section. So there's two ways to regulate the voltage on the low side of the transformer. One, we could put the transformer in regulating, or we could change our from and to nominal voltages or from and to tap. So let's just assume that my from nominal voltage is 95 kV instead. And before I save, let's take a minute and ask ourselves what's going to happen. Well, our nominal voltage on the high side is actually 100 kV, but the transformer windings are such that the from nominal voltage thinks that it's going to be 95. So our actual nominal voltage is going to be higher, so we would expect a boost on our low side. So let's see if that's what happens. I'm going to hit save, and you'll notice right now we're at 0.975, and I'm going to solve. And that's what happened. We had a boost of about 5%, including losses, on our low side. I'm going to edit the transformer. And if I go above that, let's do 105 kV. I'm going to hit save. Now I should expect about a 10% decrease from where I'm at right now. So hit solve, and that's about what I get. So let's put that back at 100. Or what happens if I change the to nominal voltage? Well, instead of 15, let's do 16. So that should raise my voltage. Well, before I do that, let's put it back at 15 and then go back to our normal conditions. So I'll solve. So normally we're at 0.975. Now let's go to 16 kV, save, and solve. Now we're at 1.04. So yes, that did raise it. And you guessed it, if we were to go to 14 kV and solve, now we're below what our normal voltage is. All right. Alternatively, instead of changing our from and to nominal voltage, we could change our from and to tap positions. So 1.0, this is unity. If I were to go to 0.95, that's going to lower my from tap by 5%, which is going to change our winding ratio by 5%. So I should see a 5% boost from what our voltage is normally at, so at 1.028. I'm going to edit the transformer again. Let's go back to 1. All right, and now let's change our 2 tap to 1.05, so that should boost my voltage by 5%. And that's what we see. And if I were to go to 0.95, that will decrease my voltage by 5%. And that's what we see. Also, remember, we had a 30 degrees phase shift with the high side leading the low side. So that's what we have here. We have approximately 30 degrees between our low side and our high side, including some additional phase shift from our losses. Let's save, and let's go back to normal conditions. Now I'm going to edit the transformer, and I'm going to take the control mode to regulating this time. And now we have to select our regulating bus ID. This can be any bus that's on the low side of the transformer that it's monitoring. So in this case, let's just make it the only bus that's on the low side that's directly connected. It's the Gilbert transformer bus. And in PowerSET, the tap is modeled on the low side of the transformer. So this 2-tap is going to move up and down between the ranges that we specify between the min and max tap here. And then our tap step size is going to be the individual step size that it takes from the 1.0 here to 0.9 to 1.1. And then our min and max voltage, well, our max voltage on the bus is 1.05, and the min voltage, we would like that a little higher than unity. So we're not going to change any of the default settings, and we'll just click save. All right, so if I hit solve, now we should be within our boundaries that we specified. And it is. We selected between 1.01 and 1.05, and now we have 1.011, and it's solved in 19 iterations. Now you might be wondering, why did it take so many iterations to solve? Well, if I scroll up, you'll see that transformer Gilbert T1 was tapped from 1.03125 to 1.0375. If I scroll up a little bit more, it tells me that again. So what's happening here is after each convergence, it's tapping the transformer up on the low side and then resolving. And it does that over and over until we are within our boundaries. So once we reached 1.01, then the software said, okay, we're good. We don't need to continue tapping our transformer. We're going to exit the solve. So that's why 19 iterations, and then it exited. If I were to edit the transformer, instead of 1.01, I were to do 1.02, and save, and solve again, and scroll down to the bottom here. Solved in 7 iterations, and then it boosted my voltage up to 1.024. So you'll see that it took an additional step size from 1.0375 to 1.04375. And then on iteration 4, it tapped again from 1.0375 to 1.05, but didn't take quite as many taps this time, so it only took 7 iterations. All right, everyone, that's all I have for today. Thank you for watching. See you in the next video. Bye.